Welcome to the programming series, Introduction to Programming Languages. Machine language. A computer CPU is incapable of understanding C++. Instead, CPUs are only capable of processing instructions written in machine language or machine code, the set of all possible machine language instructions that a given CPU can understand is called an instruction set. Here is a sample machine language instruction: 101100000011000001. Each instruction is understood by the CPU as a command to do a very specific job, such as compare these two numbers or copy this number into that memory location. Back when computers were first invented, programmers had to write programs directly in machine language, which was a very difficult and time consuming thing to do. How these instructions are organized and interpreted is beyond the scope of this series, but it is worth noting a few things. First, each instruction is composed of a sequence of ones and zeros. Each individual 0 or 1 is called a binary digit or bit for short. The number of bits in a machine language instruction varies. For example, some CPUs process instructions that are always 32 bits long, whereas some other CPUs, such as those from the x86 family, which you may be using, have instructions that can be a variable length. Second, each family of compatible CPUs, example x86, ARM64, has its own machine language, and this machine language is not compatible with the machine language of other CPU families. These machine language programs written for one CPU family cannot be run on CPUs from a different family. Related content. A CPU family is formally called an instruction set architecture, ISA for short. Wikipedia has a list of different CPU families. Search comparison of instruction set architectures. Assembly language. Machine language instructions like 1011000011000001 are ideal for a CPU but are difficult for humans to understand. Since programs, at least historically, have been written and maintained by humans, it makes sense that programming languages should be designed with human needs in mind. An assembly language, often called assembly for short, is a programming language that essentially functions as a more human-readable machine language. Here is the same instruction as above in x86 assembly language: MOV AL, 0x61. Explanation. This is instruction MOV AL, 0x61 illustrates many of the capabilities that make assembly more readable than machine language. First, the operation. What the instruction does is identified by a short mnemonic, typically a 3 to 5 letter name. MOV is easily understood to be a mnemonic for move, which is an operation that copies bits from one location to another. Second, registers. Fast memory locations that are part of the CPU itself are accessed by a name. AL is the name of a specific register on an x86 CPU. Third, numbers can be specified in a more convenient format. Assembly languages typically support both decimal numbers, example 97, hexadecimal numbers, example 0x61. Since CPUs do not understand assembly language, assembly programs must be translated into machine language before they can be executed. This translation is done by a program called an assembler. Because each assembly language instruction is typically designed to mirror an equivalent machine language instruction, the translation process is typically straightforward. Just like each CPU family has its own machine language, each CPU family also has its own assembly language, which is designed to be assembled into machine language for that same CPU family. This means there are many different assembly languages. Although conceptually similar, different assembly languages support different instructions, use different naming conventions, etc. Time to see what are the levels of programming language. If you find yourself enjoying this series, please consider clicking on like and subscribe button. Thank you.